Hello, Coach Travis here with another calculus video. So this is a video about Newton's method. In particular, it's a video about how Newton's method can sometimes fail or give results that you're not expecting. So anyway, so here's the question. We got this function e to the x minus 7x. And I went ahead and I used GeoGebra to graph a picture of it. And we can see that, yeah, it has a root or an x-intercept near 0. It also has a root around 3, but I don't care about that, I guess. Or maybe I do. We'll see. So it says, okay, if Newton's method with x0 equals 5 is used to find this root, what happens? So again, remember how Newton's method works is you have to make an initial guess, and then you use that initial guess to get a better guess. And well, let's just kind of see what happens here. So let's go ahead and what we need to do is we need to draw the tangent line at x is equal to 5. So I'm going to use GeoGebra to do that. And let's see here. So we got the GeoGebra can do this really easy. So I can just say I want x to be equal to 5, and then the name of my function is h. So yeah, you can ignore you can ignore this function right here. That's for a different problem. But the function we're working with right now is called h, and so I'm just going to enter 5 comma h of 5, because GeoGebra is smart and GeoGebra knows what h is. And so you can see, okay, perfect. GeoGebra saved me the trouble of having to figure out that when I put 5 into the function, I actually get around 113. So anyway, so there's my point right there. And then let's see now. So now what I need to do is I need to draw the tangent line. Okay, so what I've done now, you see, is I've drawn the tangent line. So I sort of spared you. I assume that at this point in your calculus careers, you can find the equation of a tangent line. So I didn't show you the details of finding that tangent line, but there it is. And again, the details aren't really that important, because again, this problem is not asking us for an actual numeric answer. It's not asking us for details. It's just asking us for the general idea of what's going to happen here. So, this is a good exercise to remind us how Newton's method works. And so now that I got the tangent line, I look for the x-intercept of the tangent line. So it turns out this tangent line intercepts the x-axis at around 4.2. And so then what I do is I then take that 4.2 and I put it into the function. So now I get the point on the function that has x coordinate 4.2, and then I draw a new tangent line. So I draw a tangent line at the new point, and that's going to then I look at the x-intercept of that new tangent line. And the x-intercept of the new tangent line is about at 3.58. And I could now keep doing this procedure as many times as I want, but I hope you kind of can see what's going to happen. What's happening is the more I repeat this procedure, the closer I'm going to be getting to an x-intercept. But the problem is I'm going to be getting closer to the x-intercept that's near 3. If I continue this process, I'm going to get closer and closer to this intercept that's around x is equal to 3. And I'm not going to be getting anywhere close to the x-intercept around 0, which is the one that the problem was asking for. So which of the following statements is most accurate? Newton's method will find a root, but it's not finding the root that's closest to 0. It's definitely finding a root. It's gonna get close to a root, but it's getting close to the root that's near 3. that's cool, that's good information, but it's not the information that I wanted. And to point out, so you might think, oh my gosh, Newton's method's terrible. But no. You can fix this. This was just the reason why it's not working is 5 was such a terrible guess. I mean, if you want a root near 0, pick something near 0. If we had started with an initial guess of 1, then this process would work much better, or it would get us close to the root we want. So again, Newton's method is awesome, but what I need you to be aware of is that you can't just abuse it. If you want to find a root that's close to 0, make an initial guess that's close to 0. If you guess something way out like 5, yeah, Newton's method might give you bad information.